Problem number 13, as unassuming as this problem seems, it's amazing how many times I see the wrong answers on students' papers. This is the second derivative graph. Okay, second derivative. We know that when the second derivative is positive, that f is concave up. And so the connection would be, you're supposed to not get confused by looking at, oh, this part is concave up, that part's concave up. Well, yeah, that part's concave up on f double prime, but it's not asking for f double prime concave up. We're asking for when f of x is concave up. So we know that on the interval from p to q, f double prime is negative, negative, negative. So that means that f is concave down on that interval. Whereas on the interval from q to s, we can see that f double prime is actually positive. It's above the x-axis. So when the f double prime graph is above the x-axis, that means that f double prime is positive, and that means that f is concave up. And so we need to look no further than the interval from q to s, and on the interval from q to s, f of x is concave up. It's exactly what we were being asked. Okay, so for problem number 14, just a review of this kind of a limit. When you replace x, anytime when x is approaching a real number from the right or left, it doesn't matter. You're still going to just try to replace x with that number. And so when you do replace x with -4, you're going to get 0 on top and you're going to get 0 on the bottom. Okay, well, we also remember then that, hopefully we remember that when you get 0 over 0, that's an indeterminate form. That means that we don't really know what the limit is, nor do we even know if there's a limit, if the limit exists. But what we do know is that when the absolute value of x plus 4, we know that the absolute value of x plus 4 is equal to x plus 4 when x plus 4 is greater than or equal to 0, but we also know that it's the opposite of x plus 4 when x plus 4 is less than 0. Okay, well, let's take a look. Let's take a look at what x is approaching. X is approaching -4 from the right-hand side. Okay, and if x is approaching -4 from the right-hand side, that means that we're approaching -4 from values of x that are greater than -4, like -3, -3.9, and so forth. Well, -3, -3.9, and so forth will always make the x plus 4 greater than or equal to 0. So all we have to do in our original limit is get rid of this stuff here, and we can replace that. We can not replace it, but we can eliminate our absolute value here, and we can go rewrite it as x equals, or x is approaching -4 from the right, of just x plus 4, and the numerator, that doesn't change, over x plus 4. Well, x plus 4 over x plus 4 is just 1, so we're going to replace that fraction with just 1, and we know the limit of a constant is just the constant, so the limit of a constant is 1. That constant is 1. The other way to look at this is by looking at the graph of the function when x is equal to 0 here, and then we have -4. The graph of the function is actually like this. Okay, whereas here's the y-axis here, 0 here. Well, that's what the graph looks like. And as x is approaching -4 from the right, the y values are just stuck right there at 1. That's why the limit from the right is 1. And whereas if we were trying to find the limit as x approaches -4 from the left, we would say the limit is -1. Okay, so 1 is the answer, and that takes care of numbers 13 and 14. And I'll see you in class.